Hello guys, welcome to my channel. In this video I am going to explain about the analysis of frame by using the slope deflection method. So in the previous video I have already explained the introduction regarding the slope deflection method. If you haven't watched that video, then the link will be in the description. Please watch that video so that you will get understanding about the procedure. Okay, so in this video I am going to explain the analysis of frame by using the slope deflection method. Okay, so as per the procedure, as you can see, it is asked to analyze the frame as shown below. Draw the bending moment diagram. So this is the frame which is given, and it consists of certain loads such as concentrated loads and UDL on each member. So we have to calculate the moments in each member. As per the procedure, the first step is calculation of fixed end moments. I am writing shortly as FEM, fixed end moments. So there will be two fixed end moments for one member, MFAB. I am denoting fixed end moment in AB as MFAB. So to calculate the fixed end moments, we should know these formulas. I have explained these formulas in the introduction video. Consider member AB. So each joint is assumed to be fixed, so that each member will act as an individual fixed beam. So if the joint B is assumed to be fixed, then there is a fixed beam with eccentric point load. That means this case, it is a fixed beam having eccentric point load. So the formula will be MFAB equal to WAB square by L square, MFBA equal to WA square B by L square. So I will use that formula minus WAB square by L square. Similarly, MFBA equal to plus WA square B by L square. So I am substituting the values. W means minus 100 kilonewton. So in the formula there is minus, so W is 100 kilonewton. So 100 into A is 6 meters. So 6 into B means 4 meters. That means 4 square divided by length square. Length is 10 meters. The value is minus 96. Okay. So finally the value is minus 96 kilonewton meter. So the reason for writing negative minus means, so this load is turning the member in clockwise direction. Therefore the moment will be in the anti-clockwise direction. So I have written minus here. So if one moment is minus, then automatically the another one will be in the positive. That means clockwise direction. Now substituting the same values in this formula. W means 100 into A is 6 square, B is 4 meters divided by length, it is 10 meters. So the value is plus 144 kilonewton meter. Now consider member BC. So I am writing MF BC. So it is a fixed beam. The joints are assumed to be fixed. So it is a fixed beam having UDL over entire span. Then the formula will be this condition. Okay, a fixed beam having UDL over entire span, then the formula will be WL square by 12 and WL square by 12. So minus WL square by 12. So minus plus. So alternatively we have to write. So minus means the load intensity is 30 kilonewton meter. So minus 30 into length is 10 meters. So L square by 12. The value is 250 minus 250 kilonewton meter. So the next one is MFCB. Now BC is completed, now CB. It is plus WL square by 12. So the same value in positive magnitude. It is obtained as same 250 kilonewton meter. So this is negative and this is positive. Now take member CD. MFCD equal to, again this is in this case we have eccentric point load. Similarly in this case also having eccentric point load, then this is the formula. So minus WAB square by L square. W is minus 50 kilonewton. So minus 50 into A is 3 meters and B is 2 meters. So B square divided by L square. That means 3 plus 2 5 square. So the value will be minus 24 kilonewton meter. Now MF DC equal to W A square B by L square. It is plus 50 into 3 square into 2 by 5 square. The value is 36 kilonewton meter. So we have calculated all the fixed end moments for all the members. So for each member we will get two fixed end moments. One is anti-clockwise and another one is clockwise. So we have calculated all the fixed end moments given in the frame. The next step is to form the slope deflection equations. So consider member AB and write the equation. So MAB equal to, the formula is MAB equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. So this is the slope deflection equation. Now we have to place the values in this equation so that we will get another equation. So in MFAB, from the step 1 we obtained MFAB as minus 96. This is the fixed end moment in member AB. We have calculated in step 1. It is obtained as minus 96 plus 2E. For the member AB, the I value is given as 4I and length of member AB is 10. So you can get these values from the diagram. And 2 into theta A. A is having fixed support, therefore slope at A equal to 0. So theta A equal to 0 and theta B minus 3 delta by L. Since this is a sway frame, the delta is not equal to 0. Now after solving this one, I got the equation as 4EI theta B by 5 minus 6EI delta by 25. So take this equation as 1. So after multiplying this value with inside values, I have obtained this equation. So we have completed for AB. Now BA. MBA equal to, again write the equation MF BA plus, here it is AB. Now it will be BA plus 2EI by L. There won't be any change in this. And 2 theta A. So here we are having B as the first letter. So 2 theta B plus theta A minus 3 delta by L. So MFBA, from the first step it is obtained as 144 plus 2E into, for the AB member I value is 4I and the length of member AB is 10 meter, 2 theta B plus A is having fixed support, therefore slope equal to 0 minus 3 delta by L is the equation which is obtained after solving this one. So I am taking this equation as 2. So we have completed for AB member and BA member. Now take BC member and CB member. Similarly take CD member and DC member and form the equations in similar manner. Similarly, I have written equations for all the remaining members. So I have explained you about AB and BA. Similarly, write the equations for BC, CB, CD and DC. So the basic thing is that first of all we have to write the slope deflection equation and substitute the fixed end moment of that particular member. The fixed end moments of the members are obtained from step 1. We have calculated fixed end moments in the step 1. So place that values here and 2E and the moment of inertia and the length of the member are obtained from the given frame. So we can substitute directly here, and these theta values are nothing but slopes. If the support is fixed support, if the support is having fixed end condition, the slope will be 0. If it is a joint, then it will remain as it is. The remaining is 3 delta by L. And after solving, I got some equation. So similarly calculate all the equations. So one thing you should observe that in member BC and CB there is no delta value here. I placed delta equal to 0 and here also delta equal to 0. So there is no delta term. So the reason is that if you observe the given diagram, the frame is a sway frame. So the frame will deflect or sway in this manner. So if you observe carefully, here the deflection is occurring only in the column. Here the columns are AB and CD. AB and CD are the columns. The swaying is occurring only in the column. So in this column and similarly in this column also. So there is no deflection in the beam. The beam is initially in this position. After swaying, it just displaces from right side. It displaces to right side direction. So the swaying is only in the columns. So only for the column members the delta value will not be equal to 0, and for the beam members the delta equal to 0. So BC is the BC and CB, it is a same member and it is a beam. So the delta value will be 0. And similarly for CD and DC, I have substituted the fixed end moments which are obtained from the first step, moment of inertia and lengths from the given frame, and here theta D is having fixed support, therefore slope equal to 0. So I have obtained 6 equations. Now the third step is joint equilibrium condition. So we have to take each joint. So there are two joints here, B and C. So we have to take each joint, apply the equilibrium condition, and we have to form the equilibrium equations. So first I will take joint B. So at joint B we are having two members, BA and BC. So I can write that I am writing at joint B, moment in member BA plus moment in member BC should be equal to 0. This is the equilibrium condition. So moment in member BA and the moment in member BC. So on adding these both moments, I should get finally equal to 0. Then only the equilibrium condition is satisfied. So we have to substitute the MBA value and MBC value. So these values are obtained from step 2 equations. Now we have to place MBA value. From the step 2 we have obtained MBA value as 144 plus 8 EI theta B by 5 minus 6 EI delta by 25. So the same I am writing here. Now I should place MBC. So that is also obtained from the step 2 equation. So it is the third equation, minus 250 plus 8 EI theta B by 5 plus 4 EI theta C by 5. So the same I am writing here. So I have placed MBA value and MBC value from the step 2. So this is the MBA and this is MBC. So these two equations I have placed here. Now add both equations. 144 minus 250, it is minus 106, plus here theta B term and there is also another theta B term. So I can add these two values, 8 by 5 plus 8 by 5, 16 by 5 EI theta B. So plus there is no theta C term here, but there is a theta C term here. So the same value will be written here, 4 by 5 EI theta C by 5, 4 by 5 EI theta C, and last we should write minus 6 EI delta by 25 equal to 0. So let it be equation A. So I am taking it as a equation A. Now we have completed by taking joint B. Now take joint C. So at joint C you can see that there are two members, CB and CD. So we can write that moment in member CB plus moment in member CD equal to 0. So this is the equilibrium condition. Now place MCB value and CD value from the step 2. This is the MCB equation and MCD equation. So these two equations are written from the step 2. So MCB, so this equation, again MCD, this equation. So the both are written here. Now add these both values. So 250 minus 24, it is 226, plus 4 EI theta B by 5. There is no theta B term here. So again 4 EI theta B by 5 plus 8 by 5 plus 4 by 5, 12 by 5 EI theta C. So this is EI theta C term and there is no delta term, so it will be as it is. So consider this as equation B. Now we have obtained two equations. So once observe that the unknowns are EI theta B, EI theta C and EI delta. There are three unknowns total. There are three unknowns and we are having only two equations. So it is so we cannot solve the unknown values. So we need another equation. So that equation is known as shear equation. So we use shear condition to get another equation. This shear condition is mainly applied for columns and horizontal loads. So AB and CD are the columns, and these three are the horizontal loads. UDL is the vertical load, so we don't consider this load while writing the shear equation. So for the member AB, I am writing that MAB plus MBA whole divided by this total length 6 plus 4 10. So what I have written is that MAB plus MBA whole divided by this certain length. So similarly MCD plus MDC whole divided by total length. So the same I am writing here. First MCD plus MDC whole divided by total length by 5. Okay. Now we have written for the moments. Now coming to the loads, there are total 3 horizontal loads. So first I will consider this 100 kilonewton. So the format of writing the equation is that 100 into perpendicular distance whole divided by total length. Okay. So before writing that, this load, so whatever the load is applied on this member is causing the clockwise rotation. So the load is making the member to move in the clockwise direction. So it is a positive value plus 100 into up to the distance up to the fixed support, because the moment is taken from the fixed support. 100 into 6 whole divided by total length. 100 into 6 whole divided by total length. Okay. So now come to this load 80 kilonewton. So 80 into distance up to the fixed support whole divided by total length. So this load is also causing the member to move in the clockwise direction. So again positive 80 into distance from point to the fixed support. It is 10 meters whole divided by total length. It is again 10 meters. So we have completed these two loads. Now take this load, the moment will be taken from fixed support D. So if you observe this load, if I take moment about D, the load is causing the member to move in the anti-clockwise direction. So if this is the member, it is moving in the anti-clockwise direction. So minus, anti-clockwise I am taking as minus and clockwise as positive. 50 into perpendicular distance, that is 2. 50 into 2 divided by total length 5. Finally it is equal to the 0. So I have written these two terms same plus, so after solving this entire equation, I got the value as 120 equal to 0. Now what I will do is that I will take LCM of these two and I will further simplify it. So on simplifying this equation, I have obtained this equation MAB plus MBA plus 2 into MCD plus 2 into MDC equal to minus 1200. So I have taken LCM. So I have taken LCM from these two terms and I have taken 5 common, so that I have obtained this equation. So this equation includes addition of MAB, MBA, MCD and MDC. So from the step 2 I have already obtained in equations in step 2. So the same equation I have written in systematic manner, all the constants, theta b terms, theta c terms, delta terms. So I have written all the equations in systematic manner. While writing MCD and MDC, don't forget to multiply with 2. So on simplifying this equation, you will get 2 MCD plus 2 MDC. Whatever the equation you have obtained in the step 2, multiply that whole equation on both sides with 2. So whatever the equation you have obtained from the step 2, multiply with 2 on both sides, so that you will get this equation. Now add all these terms. So finally, on adding all the values, I got it as 72. On adding these two terms, I have 12 EI theta B by 5, 12 EI theta C minus 36 EI delta by 25. So finally, we have added all these equations. We should equate it finally to minus 1200. So do not equate it to 0, okay? So it is finally equated to minus 1200. So with this we have got third equation. So in the step 3 we got A, B. Now this equation is C. Now this equation is C. Now A, B, C. So there are 3 equations and 3 unknowns. We can solve it by using the calculators. I have obtained these 3 unknowns. EI theta B equal to 117.94, EI theta C equal to minus 30.58, EI delta equal to 1028.92. So I have solved all those 3 equations. These are the values. So the next step is that place these unknown values which we have obtained after solving in the step 2 equations. So you will get the final moments. For example, there is minus 96 plus 4 by 5 EI theta B. The term is obtained as 117.94. So you should substitute this value in the place of EI theta B. Minus 6 by 25 EI delta. The EI delta value is obtained as 1028.92. So on substituting these two values in this equation, you will get final moment. So again, MBA, EI theta B and EI delta values are substituted in this equation so that you will get final moment in member BA. So similarly, substitute all the values in remaining members so that you will get the final moments in all the members. So after substituting all the values in the step 2 equations, that means EI theta B, EI theta C and EI delta, so I have obtained these values as final moments. So these are the moments I have obtained after substitution, and there is one small check is that, so if I take joint B, there are two members BA and BC. So the summation of these two moments should be almost equal to 0. So the summation of these two, there are equal and opposite moments. So at joint B the equilibrium condition is satisfied, and similarly at joint C there are two members CB and CD. The two values are equal, so the equilibrium condition at joint C is also satisfied. So in this way we have to calculate the final moments by using the slope deflection method. So the next one is to draw the bending moment diagram. So this is the final bending moment diagram for the given frame. Okay, so these are the final moments and these are the moments due to loads. So this is the net bending moment diagram. So what I am saying is that if you don't know how to draw the bending moment diagram, I have specially made a separate video for the same values. I have made a separate video. In that video I have explained clearly about how to draw the bending moment diagram for a frame. So if you don't know how to draw the bending moment diagram, the link will be provided in the description. You can watch that video so that you will get an idea about drawing the bending moment diagram. So in that video also I have taken the same values and explained how to draw the diagram, bending moment diagram. So in this way we have to analyze the frame by using the slope deflection method. Thank you.